How you doing, everyone? It's Mr. McCluskey. I'll be doing the notes for e-learning day 3, target 2. We're going to do applications of quadratics. Thanks for submitting all your homework the last 2 days, and hopefully you're at home and healthy and smiling. Miss Kim and I decided that for these problems here, we're going to utilize the Desmos calculator, and I think you're going to find it very helpful to especially doing these problems. We're looking for maximums, minimums, as well as intersections between quadratics. So take you through this real quickly. I tried to put some pictures in here. Question 1, Leslie Lee owns and operates Aunt Emma's Blueberry Pies. She has hired a consultant to analyze her business operations. The consultant tells her that her profits, P of X, from the sale of X units of pies are given by the following function. P of X equals 120X minus X squared. So I'm going to just take you down here. If you go to Desmos.com, I did it on my computer. You can do it on the iPad. But if you look in the upper left, I typed in, you don't even have to type in P of X equals or Y equals. Just type in the right side of the equation. So I typed in 120X minus X squared. And it gave this, you got some tools on the upper right-hand corner that help you zoom in. And the nice thing here, and I'll circle it right here, if you tap on the graph twice, it will actually give you the vertex point right there, 60 comma 3600. So I just made a quick sketch here on this graph. It was this point right here, 60 comma 3600. And what we want you to do is just analyze the question now. So how many units of pies should she sell in order to maximize her profit? 60 pies. And the maximum profit will be 3,600. Okay, the vertex was 60 comma 3,600. All right, problem number 2, we're talking about supply and demand, where a supply function and a demand function intersect. That's called the equilibrium point, or the equilibrium demand, and that will also give you the equilibrium price. So what I did is I went to Desmos. I'm just going to highlight these right here. Here's the demand function. Here's the supply function, and I'm looking to see where they intersect. Now, I did this. I had to adjust, kind of zoom in and out. The demand function was the blue one here. And then the supply function was the green one. And they intersect twice, but we're only really concerned with the positive numbers here. So they intersect at 3 comma 96. Now these numbers are in terms of hundreds, so you're going to have to then describe them in terms of hundreds. I just did the right side of the graph here for you guys and got this point right here, 3 comma 96. So the answer to the question, excuse me, the equilibrium demand of items is 300 items, and I did that right here, just kind of explain it. And then the equilibrium price was 96, but in terms of hundreds, it'd be 9,600 equilibrium price right here. Okay, and you can just see Desmos, it takes you right there again. I tapped on that intersection point twice, and it gives us that ordered pair. Okay. Number 3. Excuse me. Shanice Cole makes and sells candy. She has found that the cost per box for making X boxes of candy is given by the function C of X equals X squared minus 10X plus 32. Question A says how much does it cost per box to make 2 boxes, 4 boxes, 10 boxes? Well, all I did there was just plug in 2, 4, and 10 in for X into the function, and it gave me how much per box it would cost. Okay. I graphed it, but I also used Desmos here. It gives you a little bit better graph. As you notice, I just plugged in X squared. I forgot to mention in number 2, the equations, the variable was Q, but when you put it into Desmos, I recommend that you just use X. It's very familiar with X, so don't get flustered by that. So going back here, I plugged in the equation here. I tapped on the graph twice and got a minimum 5, 7. That's going to be important because we're looking for minimum. The point on the graph, the point that will make the cost per box as small as possible is that vertex. And then in letter D, I just explained it. It's going to take 5 boxes to keep the cost per box at a minimum. And then the minimum cost per box is 7. That's our Y coordinate. Okay? So what we'd like you to do is go through the worksheet. We want you to use Desmos and look for your mins, maxes, and intersections. Hope you have a good day. Take care.